Okay, this is AP Physics, Unit 2, Dynamics, the exam free response question number 2. And what we have here is we have a block at rest on a table with no friction, and it's pulled with a force probe. So I know they're talking about a lab. They want to test what information have we learned from a graph. And we know when we have a graph, we have force versus acceleration, and the slope of that line is equal to mass. And they want to know what is the mass of the block. And unfortunately, a lot of you just went and found 1 point or didn't show how you knew it was 3. But remember, on this exam, I highlighted, clearly show the method and steps that you use to arriving at your answers. So finding just the answer wasn't enough. You needed to show how you got A. So when you did that, you showed that rise over run is equal to mass. So there's 1 point for indicating that you know that the mass of the block is equal to the slope of the force. So somehow you had to show rise over run, and then you needed to indicate that you got 2 points when we do a graph. So 15 newtons and 0, I used the origin, and at that 15 newtons, it was 5 meters per second. My units cancel out because I know newtons is kilograms meters per second squared. Cancel out and I have kilograms, and I get 3 kilograms. So to get the 3 points, you needed to indicate that you got a graph, rise over run, showed what values that I used 2 points, and then the kilograms. The next thing they wanted to know is the block is placed on a rough horizontal board with a friction, static friction, and a kinetic friction. So when they gave me both, and then they say a 10 Newton force is applied, so I'm going to apply 10 newtons to this. At no point do they say that we know it's moving. They want to ask, what is the acceleration? Well, an answer for acceleration could be 0. Or is it moving? When they give me both, and we had a homework problem like that, I need to decide, does it actually move? Is this 10 newtons great enough to actually make it move? So when I go to the problem, I just set it up and figure out what is the static friction value. What is the max going to be? So I'm going to do my free body diagram, and the tension must overcome the force, the S max, to move the object. I know what the force is, I know what the static friction is, coefficient, and the kinetic, but I'm going to just concentrate on the static. So I sum up my forces in the x direction, and if it's at rest, because I'm going to use the static, I can get rid of that value. And I'm going to see writing this out is going to benefit me later on in the problem. The sum of the forces in the y direction, because why do I have to do this? Because I know static or friction in general is the sum is equal to the friction amount, the texture, versus how hard it's being pushed down. Well, the only place I can get that is the normal force from the y direction. So the tension is equal to, I took this value, put it into there. I have all these values, and I get the force of friction that is necessary to overcome my static friction value of 0.05 is 15 newtons. Well, it's only being pulled with 10, so that's not enough to overcome the static friction, and I need to say that. I know that the force to overcome, so 15 newtons is needed to overcome the static friction. The applied force was only 10, so it's not enough. Therefore, the object will stay at rest. I get 1 point for the justification, 1 point for saying it's rest, or I could have easily just said acceleration is equal to 0 there, and I needed to show why is because it takes 15 to overcome, and I only had 10. So let's move to C. On C, they are going to say an additional block with twice the mass and twice the surface area of the original blocks is placed on the same horizontal board. And at the end is levered, so basically I'm saying I'm going to keep lifting. I've got a box on here, and I'm going to keep lifting. And at what angle will it start to slide? And I need to justify my answer. And equations must be part of your reasoning. So I have to show the math. They told me right there, I need to do the math. Well, then let's just treat it like a math problem. So what I have is I now have twice the mass versus what I had my original mass. My force diagram becomes this. I'm going to remember that the portion of my mass in the x direction is the cosine. The portion of my mass that's going to help me slide down the hill is the sine of that. And it'll be raised until movement starts. So it has to overcome that S max that we had before. How the texture of it, that's what the use of K is really my texture, is 0.5. So let's sum up my forces in the x direction. When I don't know what to do, that's where I start. So I'm saying this direction is positive. I have my static friction working against me. So it's a negative because I want to go down. This is my positive. This is what's pulling it down the hill. And I said that's at rest. So I rewrite that, solving for f of s. And I know f of s really is the static coefficient times the normal force. I don't know the normal force, but luckily I can go sum up my forces in the y direction. And I have just f of n is what I had, and I had the portion of it going in that direction, which was the cosine this time, and I have no movement. So f of n really becomes mass times gravity times the cosine. So I can go back to here in my x direction, substitute that value in, and I have all of a sudden this really big equation, but I notice I have mass on both sides and the mass cancels out, so that immediately tells me, and I get a point for that, mass cancels out, so mass is not a factor when the blocks will move. Mass doesn't matter. That's what the equation tells me. All that matters is the angle and the texture. So how much mass I put on this lever doesn't matter. All that really matters is the texture and what that angle is. So, and they want to know what that angle is. So both blocks will slip at the same angle, again, because mass doesn't matter. I get a point for that. I need to figure out this angle. Sine over cosine equals my tangent, antitangent, put my value in there, and I figure out my angle is 26.6, and I get a point for that. D, which block, if any, has the greater acceleration? Calculate the acceleration and justify your answer. Well, basically now we're going to say I'm going to have movement. I am going to change my kinetic, my friction, to F of K. I'm using this situation now. But I already did the math up above for a portion of this, so why would I want to make it harder than it really is? I know up here, the sum of my forces in the x direction was static, and I'm just going to change that to kinetic, mass times gravity times the sign. And I substituted in this. So my equation really is this all over again, except this time I don't get rid of my acceleration. I'm keeping it. Up here, I got rid of it. Here I got rid of it. I'm using the same equation. This time I'm keeping it because it says I have kinetic. I'm going to put in this. I'm going to cancel out my masses. So both, that tells me again, as soon as I get rid of the masses, both mass blocks will have the same acceleration since the acceleration is independent of the mass. I just have to state that. That's what it means when I cancel those out. It means mass isn't a factor. Then I rewrote the equation for acceleration because that's what they wanted to know. And I used here again to justify that's my acceleration.